Welcome to the virtual battleground where hackers and security professionals test the strength of passwords, and only the most resilient survive. The password cracking phase is like a digital duel where attackers employ cunning techniques to decode passwords, while defenders bolster their defenses. It's a race against it's a race against time and algorithms, where the victor gains access to guarded progresses of vicious information. So some concepts that we have to know before starting with password cracking. And we will only cover the fundamental concepts of password cracking because as with everything in cybersecurity, the trends always change and you always have to be up to date with the changing trends. So hashing is a process of converting input data or a message into a fixed size string of characters, which is typically a hexadecimal. This output, known as a hash value or hash code, is generated using a mathematical algorithm called hash function. The primary purpose of hashing is to verify the primary purpose of hashing is to verify the integrity of data and quickly retrieve specific data. It is commonly used in data structures like hash tables and cryptographic applications to store and compare passwords securely. Popular ones are MD5, SHA-256, and TLM, etc. So basically, what hashing means in layman terms is that you have a plain text, any string of text, and you have a cryptographic algorithm called a hash function, which you apply to the text, and then we have a gibberish form of text called hash text. You cannot decrypt the hash into plain text, so it's a one-way trip, but this ensures the integrity of the string or the hash text. So this is used to verify the integrity of data. How is that a cheat? You might ask, and that is because each text or string, if goes through the same hash function, it always will generate a unique hash. And no two hash values can be identical if the data is unidentical. So for every unique data, the hash will be different. So that way, if somebody tampers with the data, the hash will be different, and that way you will know that the data has lost its integrity. And how it works to store passwords is that when we store passwords, the same algorithm, the same hash function is applied to create hashes, and the passwords are stored in hash text. And that way, if a data breach happens, the bad guys or the attackers, even though they have the password right in front of them, they cannot decipher them or read them because it's in gibberish. So they need to decrypt it, but they cannot because it's a one-way process. But actually, but which we will see in password cracking in the demonstration, that uh, then what we do to crack these passwords is that we actually have a word list, or we use a brute force attack to guess different combinations of letters. For example, if we have a password called password or 1 2 3 4 5, so it will have a unique hash. So the attacker will try to generate multiple hashes using the same hash function. For example, it's SHA-1 or MD5. And if the generated hash from that word list, or by guessing the different common letter combinations, if it's the same as the target hash, then that means their plain text string would also be same. So for example, in this case, if we have this hash string, for example, this is the hash string for the word password. So if the attacker is going through a list and it is generating different hash types, different hashes for different strings, so it finds a hash that matches this hash. That means that the word from which the hash was generated would be the same as the word used for this hash. So uh, in short, when we are cracking hashes, we actually don't crack hashes, we actually compare hashes. We are not decrypting them. We are just generating multiple hashes, and if it matches the target hash, then that means we have the password. And again, hashes versus encryption, just like I told you before, that it is a one-way process. We have plain text, we encrypt it, we get encrypted text, but it can be decrypted using the key to the plain text. But hash cannot be decrypted. It's a one-way process. And another difference is that encryption is used to ensure the confidentiality of data, but hash is used to ensure the integrity of data. Yes, just like in the example I talked before, sometimes it can also uh, be used for confidentiality in terms of if we have hash passwords. But the main thing is to make sure that the integrity of data is preserved. In case of data, in case of files, uh, if we encrypt a file, the eavesdropper or the middleman or someone gets the data, they cannot decipher it without the key. They cannot pick it. But what hashing does is that they cannot tamper with the data, because if they do, the hash value will be different. And now another important concept, and this is a little bit advanced concept, and we will not actually cover this in our practical demonstration. Uh, but salting is a security practice used to enhance the protection of stored passwords in a database. It involves adding a random value, which is called the salt, to the password before it's hashed. The purpose of salting is to make it more challenging for attackers to use pre-computed tables like rainbow tables to crack passwords. Each user's salt value is unique, even if two users have the same password. Salting is an effective way to defend against various password cracking techniques and is considered a best practice in password security. This is added to the course in terms of mitigations. So if you, uh, because we're going to cover hash cracking, so you can actually make your hashes stronger, your password stronger, and more difficult to crack by applying salting. So again, we have this password welcome one, and normally with the hash algorithm, it will have a hash. But what salting does is that it adds an extra value, for example, A, B, C, 1, 2, 3 to J with that welcome one before it is hashed. And then uh, every time you are going to enter this password, the salt for this password will be preserved in the password storage. And every time it goes through the hash function, it will apply the salt to the password, and then it will compare hashes. So that way it will know that you have the right password. Why is this beneficial? Uh, because at a glance, you're thinking that it's not benefiting us because we just have to know the password, and the salt is going to be applied on its own, and then we'll have the hash. But we have something called rainbow tables or pre-computed hashes. And we'll also see an example of that in a tool called Backstation, where the hashes are not calculated on in real time, but actually there are because bad guys are doing this stuff for a long time, and there are a lot of data breaches from which different attackers have uh, pre-computed different hashes. So, for example, if you have a word password, there's a specific hash for it, and bad guys are always trying to crack various passwords from data pages, different credentials. So they have made a list of passwords and their hashes pre-generated. So it what it does is that it makes the cracking process very easy. For example, if you're using a known password, they already have the hash for it. They don't have to calculate it on runtime. So it makes the cracking process very easier because the machine or the cracking systems do not have to generate the hashes in real time, and that's what takes the uh, that's what is most time consuming when it comes to password cracking hashes. So when you have a pre-computed table like rainbow tables, it's just matching the different pre-computed hashes with your target hash, and that is way faster than uh, trying to calculate hashes in the initial phase and then comparing them. So it just takes the first phase out of the equation and makes the process very fast. So that's why sorting is used. And again, uh, just like I was talking about the benefit, we can see the example. We have same password here. Uh, it's in lead code, basically numbers, and numbers are used in replacement of different words. different letters. Passwords, it's passwords, but if two guys use the same uh, password without the salt and they have the same hash function, it will have the same hash. But if you use different salts to them, then we'll have different hash because each hash is calculated on each letter of the it combines it calculates based on every letter of the string every and that way the resultant hash would be different. So using different hashes, different salts for different password, using different salts for same password can result in different hash. And that way, even if someone has a pre-computed hash, for example, this F4C31A for the password value, they still won't be able to crack this because of the salt value will make the hash different. And now two common types of attack we need to discuss. There are many other types, but all of them just use a different variant of these two basic attacks. And first we have dictionary and then brute force attack. Dictionary attacks, these attacks involves using a list of common words and phrases to guess passwords. A good dictionary is essential for successful password cracking. While a brute force attack systematically tries every possible combination of characters to crack passwords, this can be time consuming but effective. So basically, brute force is your worst case scenario. It will try to guess the password, and theoretically, if you have infinite time, it can crack any password. But that is a big if because time is in any penetration test or in any case where we are trying to guess password, we always have limited time. Nobody has infinite time. So that's why brute force is worst case scenario, but nobody's gonna try uh, to crack your password if it takes more than probably a day. You so that's why we use dictionary attack, which has a list of common words and passwords which people use. For example, the Rocky list is very popular. Daniel Messler has a popular list for different passwords. For example, top 100 admin password, top 100 Wi-Fi passwords. What it does is that it plays on the human psychology that humans tend to use easy and common passwords. And if if that's the case, you don't have to brute force their passwords. You can use that list found from different data breaches, which people often use. The same password has found in those data breaches, and then you can generate hashes from them. That's the first phase, and then we can compare those hashes with the hashes with the hash we want to crack. And if they match, that means the target has used the same password. So again, as you can see, it takes less time. If they take more time, it is adaptable based on location because it is less intensive, resource intensive. It does not need to use a lot of uh, resources from the system like GPUs and heavy CPUs. So most of the tools online time you can find online tools that can use dictionary attacks or pre-computed hashes that don't even generate hashes on the runtime, but they actually have pre-computed hashes, just like we talked before, rainbow tables, and there's a two track station that we will cover based on that. But brute force requires advanced password cracking software and hardware because it is very resource intensive. We need GPUs, we need TPUs, we need GPU clusters to do that because to make it more fast. So our first application which we're gonna use is Hashcat. This is the first application we're gonna cover in our demo. Hashcat is a popular open source password recovery tool used for cracking password hashes. It supports a wide range of hashing algorithms and attack modes, making it a powerful choice for security professionals and pen testers. Hashcat is known for its speed and versatility, capable of running on various platforms and supporting both CPU and GPU acceleration. So Hashcat, as I said before, it is used for hash cracking. It is open source, and the best thing about it is that it can use both GPU and CPU acceleration. So you can actually add a GPU cluster or a single GPU to it, and that can make its cracking speed much faster. It's available for both Windows and Linux, and it is you can say the industry standard for password cracking. Then we have John the Ripper. Of course, we have heard of Jack the Ripper, but this is John the Ripper. Uh, Again, with many things in cybersecurity, they have a thing that they need to make their tools have a cool name. So often abbreviated as John, mostly when you are using a Linux, they often type or use the uh, word John instead of full John the Ripper. So it is a widely used password cracking tool. It can crack various password hashes using different attack methods, including dictionary attacks and brute force. John the Ripper is known for its speed and flexibility and is available in both community and pro version. So in Linux, in our demo, we'll use the community version, but it also has pro version, which have like more advantages to it. Unlike Hashcat, which is open source and free, John the Ripper is a commercial tool. But although they look similar, they are both password crackers. But for some cases, John is a little more suitable for some use cases as compared to Hashcat. And in some cases, Hashcat is more suitable. So we're gonna cover John the Ripper also in our practical demonstration. And then the final tool is FlexStation, which I teach a little bit before. And it is a web-based password cracking tool and hash database that provides a large collection of pre-computed password hashes. Users can check if their password hashes are in their database, which is useful for understanding the strength of their passwords. It also allows security professionals to check the vulnerability of their system by verifying if common passwords are present in the database. Again, just like I talked before, that there's a thing called pre-computed password hashes, and CrackStation actually utilizes that. It has a pre-computed password hash list for common passwords. So before trying John or Hashcat in your during the penetration test, most of the people uh, most of the system administrators, network administrators, or any use case, web developers, they use common passwords. So it's always good to check those passwords on CrackStation first, because if it's a common password, it will be already be cracked, and CrackStation will give you the answer. And it has a comprehensive list. It doesn't cover only one or two hash types. It covers multiple common hash types like MD5, SHA-1, SHA-256, SHA-512, and TLM hashes. So that is often a go-to tool to use during your password cracking phase. Hi, so today we will uh, look at password cracking. This portion of the video will cover most types of passwords, not all types because there are a lot of types of passwords and encryption and hashes. So we won't cover them, but we will cover most common types. And we will look at two tools and one additional tool, but uh, the third tool would be just an a fast alternative of the first two we're going to look at. The first two are very crucial. First is Hashcat and second is John the Ripper. So first of all, we will look at Hashcat. This is our directory. I have actually made some directories related to Hashcat. So some passwords we will try cracking with Hashcat, some with John, and I will also discuss why we use one over the other. And this is a directory which contains the word list. So basically, this has a top 100 Wi-Fi password word list, and the other is RockU basically, which we're also gonna use in other videos. But basically, it's one of the biggest word list ever found in ever found in a data breach, and it consists of more than 14 million credentials. So it is always good to use that. So these are the two word lists we're going to use. And first, we will look at Hashcat. So this is uh, in password cracking, you're really going to need just uh, two of these tools for most of your work. And that also depends on your case, but most of the time you won't even need anything other than Hashcat because this is an extensive tool. It's an open source password cracker. It can utilize your GPU, not in a virtual machine, when you're using a virtual machine or a container, uh, because of the hardware limitations, it cannot do that. But if we were using a bare metal machine, we could also it could also utilize your GPU for faster password cracking. But it is an extensive tool. You can just see that it has many uh, things in here. It's an exhaustive list, and we won't cover everything, but just the main things. So first of all, Hashcat is used for password cracking. It can crack almost all kinds of password. If you just look at it, these are the modes for it, basically password cracking modes, and it can crack most of the known password types or encryption types. We have MD5, which is very popular, SHA-256. We can crack these, and these are the numbers which are basically modules which are used to tell Hashcat that what kind of hash we want to crack. And then there are more. This is another type of MD5 SHA salted passwords, and we have discussed some of this in theory, but again, this is just a whole deep concept that we cannot cover just in this small video. So I'll encourage you to look at that. But most of the time during penetration testing, you won't have to know very deeply about every kind of encryption and hashing. We just need to, and again, with cybersecurity, in cybersecurity, that's the general case, that you need to make do with what you have, and you just improve your knowledge on the runtime according to your problems and your needs. So you don't have to know everything from the start, but you should be willing to spend time. If you get stuck on something or if you have some problem, you need to be a good problem solver. If you have any problem, you need to be ready to solve it. Okay, so there are different types, and for example, then there are just this is for Wi-Fi, WPA, different types of Wi-Fi. As you can see, it has also categorized it network protocol. So we're gonna utilize these also, especially this to crack Wi-Fi password. And then it is the NTLM protocol for networking, and then Windows LM protocol, which is used by Windows, NTLM, which is this is also uh, something we're gonna crack. For example, you exploit a Windows machine and you do a hash dump and extract the hashes of other users and their passwords. So in encrypted form, so you want to crack them, so you can use Hashcat to crack those. So that's why it's very beneficial. And then we have some networking machines, Cisco, FortiGate for Mac OS, MySQL databases. As you can see, it just covers everything. It's very exhaustive. So we cannot cover everything here. Wirecraft containers. This is very good. Uh, TrueCrypt, another file encryption application, BitLocker, Android, Apple, PDFs. We can crack PDFs. We can crack MS Office encrypted files, open ODF files, open document format files, 7-zip, Bitwarden, KeePass, LastPass, 1Password. Every application which has something to do with encryption or hashing or passwords, you will find it here. Skype, Telegram, TeamSpeak, even blockchain, something related to blockchain. Again, depending on the type or depending on the module you are cracking, the encryption type, it will require some things, and for some, it will just do it by default. Also, there's a difference in speed, which we will discuss. So these are the types of encryption or passwords that it can crack, but how we can use it as is that we need to know a few things. So first of all, we're going to use Hashcat, and then we need to tell it the hash type. So from that list, from that exhaustive list, for example, if we want to crack MD5, we will have to know the number, module number for it, 0, which is for MD5. So we will use Hashcat minus M and then give it 0. It will know that we wanted to crack the MD5 hash, just like this. Instead of 1000, we will use 0. Then we need to tell it the attack type. So it has uh, two basic attack types, and general, other than that, it has more attack types. So total attack types are five, but we use two generally. uh, and that is the case, for example, in most crackers, password crackers. One is brute force. As you can understand, it will brute force the password. This is very exhaustive because it is just randomly trying to guess the password, and the bigger the password is, the more in length it is, the more alphanumeric characters it has, symbols it has, the more harder it will be to crack it. And then we have a word list. So we can use a word list, a dictionary, just like in this case, which has predefined password, and it will create hashes and then compare the hashes with the password with the hash we're gonna crack. And if it matches, then we will have our password. So depending on your need, sometimes this works, sometimes this works, and sometimes usually using a word list is better because you it is more fast. And uh, for example, even for a brute force attack, even for a simple password, it will take some time. So you can just try a word list first. And in any case, if the cracking a password takes a lot of time, for example, a whole day, then it's not worth doing it. Whether either it's word list or brute force. And then there are different things. For example, word list per rule. So we can define some rules as to different types of rules. This is a somewhat advanced thing, but it actually changes the how the word list works, the combination of words work, and it tries different alterations with it, and that way it tries to guess the password. So this is something you don't use normally. Most 99% of the time, you will find your password with either using a word list or brute force. And then there are other things, combinator association, that is also similar to this, but just a different pattern. And then there are performance modes, then device type. By default, if you are using a bare metal machine, you have an extra GPU or a GPU cluster, and you have your drivers installed, uh, especially for NVIDIA works better for in Hashcat with Hashcat. So you can it will pick up your GPU, and otherwise it will use your CPU. And in this case also, in a virtual machine or a container, it will use your CPU. And if not, if for example you have a GPU but you want it to use the CPU, then you can select your device type when you are uh, writing the hashcat command. At the runtime, you can define the device type. Most of these things are irrelevant to the topic here. So we will just now start with the cracking process. So first of all, I have this directory and I have different types of hashes. MD5 is very common. SHA-256 is very common. We'll try that. NTLM, if we have, just like we talked before, that uh, in if we get a password hash or multiple hashes from Windows, those are in NTLM form. Those are called NTLM hashes, and we can crack those also with Hashcat. This is Wi-Fi WP hash. Normally, when you, uh, which we also will look in the wireless penetration testing phase in that video, that you can, when you capture network traffic, you can crack it with AirCrack, which is part of the Air framework. And I won't go in detail uh, about that because we have a whole video for that. But you can also actually convert that packet capture, network capture, into a hash, and then we can crack it. So this is MD5 hash. We'll have to crack it. This is SHA-256. So it is more secure than MD5. And again, the basics of these will be discussed, is already discussed in the theory. And so this is more secure. As you can see, it also has a greater length. And this is, there are two passwords actually we're using for Wi-Fi. So this is, or it works, the type, and then this number is same. And then these are different things. For example, SSID, SSID, the password, different portions of the Wi-Fi capture hash. And these are two NTLM hashes we're gonna crack. So first of all, we'll use hashcat. Then we give it the attack time, and 0 is for brute force, and 3 is for word list dictionary attack. So that's the two you need to remember as a beginner. First, we will try a dictionary attack, and then M, as I already discussed before, that it is the module. So what if you want to crack a certain type of hash, that's normally 99% of the case you can't, and also we don't want to crack multiple types of passwords or hashes at the same time with hashcat. So we'll give it 0 for MD5, and this is the file basically. So it already knows that we want to crack MD5, and our file name which we were going to want to, which has the text file which has the MD5 hash. That's the name of that file, MD5, and then I will give it the word list, which is this rocky.txt. So it is in this directory. So we're going above a directory, then word list and rocky.txt. So now we will start it. Sorry, we are actually not in the hashcat folder. We need to go into the hashcat folder. And again, hashcat dictionary tag, MD5, the file name, and the word list. So it should work. So again, just like we discussed before, it will tell you the device type. If I go back, so it is telling me what device it's using. So I have a Core i5 12 Gen processor, so it is using that by default. And because this is a virtual machine in which I'm running this Kali setup, so that's why it cannot use the GPU. Although I have a GPU on bare metal, but in this virtual machine, it won't work with Hashcat. So that's a limitation of using Hashcat or generally using any password cracker uh, in a virtual machine. And it has two hashes because in this file we have two hashes, and now it has started cracking it. So again, it is trying one by one. For example, again hash mode 0 MD5, our target file is MD5. It has started because it is brute forcing it dictionary attack, but still brute forcing it in a way that it is generating hashes on runtime from our password list, and it's gonna stop when it matches or until the word list is fully exhausted. So this was the first one out of 14 million plus credentials, and the speed is 1315 hashes per second. If you are using a GPU, this is much faster. Uh, if you're using a very good GPU, for example, in the RTX series 2080, 3080, then it's gonna go very fast. And it has recovered 0 out of 2. Two hashes we have, and it has recovered 0. So this is how it's working. We can see it has recovered one password. And as we can see, it has found both the passwords. One is Johnny, and we can actually, instead of scrolling here for the password, we can do is to use hashtag again and then show command. This will tell us all the password has cracked. So we had two hashes MD5, and one was password one, and one was a match for John. So this was all for our MD5 section. And you can actually do the same as we did with MD5 for SHA-256. So I won't cover that. Just like we used a module for MD5, we can use hashcat help and then grep for SHA. This will find all the modules related to SHA, and then there are other versions, so you can use the version accordingly. So I won't cover that. Now we'll go to the next, which is NTLM hashes. And for NTLM, we have the module, we have the attack, we have the attack 3 again. This time module is 1000, our file name, and then again the route to text list, and we begin. Just like with SHA-256 MD5, this time we have Windows hashes or hash term. We want to get Windows password. We can just save those hashes in a file and then use module 1000 with hashcat, dictionary tag, or word list, and it should find it. I've already found one password, and as we can see, it has found both the passwords. Again, we will use this, and again, we just use the same password. This time the hash type was different, NTLM instead of MD5 for SHA-256. It has found it, and this all depends on your CPU and GPU. The most faster they are, the more faster the cracking process will be done. Now we will start cracking the Wi-Fi, which we already looked before at the beginning. We have the two Wi-Fi hashes, and there are some other things which need to be part of the hash or hashcat to crack it. You can look at that in detail. You can search for WPA hashcat, and it will tell you what things it requires for to crack a Wi-Fi password. We will use hashcat again. This actually this time we will try brute forcing. And for Wi-Fi WPA hash cracking of this type, it has actually different types. What for this one, I will, you can actually look at that in their documentation also. And for this type, where we have the WPA, the PVKDF2 or PMKID, which is the key we capture during the Wi-Fi capture process. And then this EA pole, basically this consists of the SSID, the client, the AP, MAC, and the client MAC, and all of these information need to be in the hash with this key, and that way it can crack it. Well, we can see WPA01, and then this is the EMKID, and then this is the portion which is basically consists of the network MAC, the client MAC, and the name SSID of the network. Because we are just focusing on the cracking phase. For this, I will use actually the top limit Wi-Fi. You can actually find this list and list similar to that on GitHub or internet or on the internet. Daniel Messler has a lot of different lists relating to uh, bad credentials available on his GitHub repository. So you can try those, not just for Wi-Fi, but for different things. So this is inspired from that. And now we will crack it. And because this first we will try brute force attack because I've already shown you how to do dictionary attack. So for this we will try the brute force attack. And with brute force, you have to put one question mark for one letter, you can uh, actually tell Hashcat to what to which length you want to crack the password. For example, if it's 8 letter minimum, you will use 8 question marks with either A, L, or T. A means alphanumeric. You wanted to try both the alphabets, English letter alphabets, or the numbers. Or you can try letter, which means English alphabets, or you can try D for digits, just A. So if you think it's the whole password consists of numbers, you can try D for that. This way. If you think it's letter, then you can do this. And if you are not sure, you can try. And also, for example, if you know that 6 letters are, if you have a guess that 6 letters are letters, then you can try question mark L for 6 letters and then question mark D for the other two. So this way you can actually tell uh, whole length of the password you want to do this. For this, we will try alpha. It should find only one of the password because the other two is are too good for or takes more time. So I will just bank on it to find the first one because that consists of numbers. Sorry, three is the first. It has started and it has not covered either of the password. Just and this is going to take some time because again, just like I said before in the beginning, that brute force takes a lot of time, and it's the last case scenario that uh, when we have no other options to use this, and even then, if it works in an hour or two, or at most a day, otherwise, this is not the way to do it. So basically, this was just to show you that we can use alphanumeric, but this is gonna take a lot of time. And actually, zero is for dictionary type. We again forgot that. And three is for brute force. So we were actually gonna use digits, and because I already know that the password is numerical one, so it's faster to use this. In a scenario when you don't, in the scenario where you don't know what's the password, whether the password is in letters or numbers, then it's okay to use alphanumeric, but it's gonna be the most time consuming because as you can see, there's a simple calculation that we open the calculator because there are only 10 numbers from 0 to 9, and that's how many tries it's gonna have only for 8 letter password. So as you can see, this is also telling us the indication. If you have a long password, uh, at least 16 letters or 14, I think it should be 16, and it's alphanumeric, then it's hard. For example, if it was alphanumeric, it would be 65 to raise 2. So as you can see, just by adding letters and alphanumeric uh, options, it goes so high. And for example, if it was a digit, only digit password, but it was 9 or 10 lengths. So basically, 10 to raise 10. As you can see, the number goes big. So first, I think it was 100 million, but now it's 10,000 million. Increasing the length makes the difference, and adding letters and a combination of letters and symbols and digits makes a lot of difference in your password. And also, when we are brute forcing it, it makes it harder to brute force it because of the it's because it just takes too much time to because of the length of the password. Now we will begin the brute force. And it should be done quickly. It has recovered one password and it's not gonna find the other one because that's not digit. So I waited. Now we can see that it has found that was the key, and this is the SSID, the MAC address because that was just made up, so it doesn't look very different. But this is the network MAC and client MAC. You see SSID, AP access point 01, and this was the password. So that's how we can do a brute force. But again, just because of the limitations we have seen with brute force, that's why we don't use brute force normally, and we actually use dictionary tag. So now you will see that it is much better if your word list contains the words that can match with the password. And this time we'll do a dictionary tag with top 100 Wi-Fi passwords. And because again, top 100 is basically the top uh, password used by on Wi-Fi's because people tend to use common passwords. They don't want to remember unique passwords, so they use common ones. And most of the time, word lists have a lot of password used by people. In a penetration test, if you wanna after a penetration test, if you wanna crack passwords, it's always better to do a dictionary tag and use the word list because most of the times the password used by people in are present in those word lists. And again, as you uh, can see that it was very fast and it found the first password already in the last attack, so it is not showing it this time. But it has also found the second one this time, which was hashcat exclamation mark. This was the SSID, and again the different information. And hashcat actually has a port file which I can remove and try it again this time so that it finds both of the passwords. Because once it finds the password, it saves it in this file. So if I run hashcat again, it won't start cracking again, but tell me that it has already found the password. So I will create that to start the cracking process again. This time I needed to find both the passwords with the word list. And as we can see, it just took an instant because this time it is not brute forcing it, uh, not trying to guess on its own, just taking words from the word list and then generating hashes, comparing them, and it has found both of the passwords. Hashcat exclamation mark 1 and 1 to 8. This was all for hashcat. As you can see, it is very useful. We can crack multiple types of passwords. More, this was just a very short example of a few types, but it is very exhaustive and it can crack almost any type of password. So now we will try another tool, which is John. And John is a bit different in a way that in some cases it is better to use John for some parts, for some types of passwords. It is an alternative to Hashcat, but in some cases it just works better because it has some modules to crack some passwords better. Not that you cannot crack those passwords with Hashcat, but some in some cases just better to use John. And we will look at those examples in which John is mostly used. So basically, we have ID RSA. Basically, this is a private key and a public key. So if you're using a private public key encryption, which I'm not going to go in detail, uh, and you have a passphrase on it on the key, and in some cases or during a penetration test, you exploit a server and you find the private key, but you have a passphrase on it. So you need to crack the part because you can use the private key to connect to some host, some server using that key. But in some cases, when it has a passphrase on, you need to know that passphrase to connect to that server. So this is something you should know by default beforehand. Also, if you are a Linux, if you have some background Linux, you should know it. Uh, Public private key encryption is used mostly in SSH instead of passwords, so that only authorized machines can connect to the server. So I have this private key, and but this is protected with a password, and then the public key. So I have this. Uh, Actually, I will remove this and generate it again. So basically, this key has a passphrase. So even if we just have the key, we cannot connect to the server because we need to know the passphrase. And this is where John comes in handy. We can use a function called SSH to John, and this will actually extract the hash of the passphrase from the private key, and we will save it in another file at idsc.txt, which we now have. And we do this. So this is the hash that is used by the private key. The hash of the passphrase used by the private key. So we need to crack it if you want to utilize that private key to connect to the server. So we can use John now and just give it the file name and then the word list again. I'm using copy.txt here, this file, and John should crack it. As you can see, it has cracked it, and yes, the password was password block. So these are some of the things where John comes handy. Again, in another case, this is very crucial. For if we crack a Linux machine, we know that we have the user details in etc password. As you can see, we have two username here, Caddy and Jimmy. And in Linux, the password details are actually stored in this shadow file. And this is mostly accessed by, it is not accessible by normal user, but only the administrator. So we have the password and it is actually encrypted in ES-script, which is a type of encryption. And this is the password. So to crack a Linux password similar to this, we need to get both the password files and the shadow file. And John has a tool called nshadow, which combines both of them in a file, and we can name it anything. output.db. I will call it output.db. And again, for one shadow, we also need to use. So I will catch it. So now it has combined both the password file and the shadow file. So basically, it has combined the username and its details with the password. And this is actually how Linux uses it. When you enter the password, the shadow file, the password file has a placeholder for the passwords used in the shadow file. And on the runtime, it combines it. Basically, what we are doing here, the shadow process, it does that on runtime, and then it checks whether the password was correct or not by generating its hash from the runtime and combining it. So that's what we have done here. And now again, we can use John and give it about this. And we can also tell John what format is it, because it is using a specific encryption yes script, and it's basically spelled as yes script. We have told John that it is using a type of encryption and the file and the word list, and it should crack it. So it has found one password, which is Jimmy, and yes, the password is 128. And if it finds any password, then that means it's a correct password because if the hash is the same, then the password is same. So what how password cracking works is that John or Hashcat, they uh, don't decrypt the hash, but actually generate hashes. And if a hash matches with the target hash, then it means the string was the same string was it. So basically, in this case, it generated hash for this string and compared it with the target hash, which we found in our shadow file. And because it found it to be the same, both of them to be the same, so uh, it came to the conclusion that the string that was used to generate that hash would be same as. We can let it run for longer. If you want to find the second password for Kali also, I don't mind it because this is a virtual machine, so it doesn't matter. But we can also stop it because it just goes through the list, and if the password is in there, then it will find it. And with John, we can use the minus show option to show the password that it has cracked. Our last example is basically a zip file. And this is a password protected file. So if we try to extract it, it will ask for a password. If we use password, it won't extract it to anything. So we can use another function of John, which is zip to John, and we can input the file, and then we redirect the output to a hash file. Basically, we have generated, we're gonna generate a hash for the zip file. So John hashcat, they're always gonna work with hashes. So if we have any password, we need to convert those into the required hash type for that specific module, and then we're gonna create it. Okay, so it should have yes, it has generated the hash file. We can create it. This is the hash used by the zip and for its password. And now we can just use John and the zip file, and it should crack it. Yes, as you can see, just in an instant, it has found the password for the zip file. So that was all for John and Hashcat. These both of these tools are pre-built in Linux, Kali Linux especially. So most of the time you won't need anything other than these. And then there's another tool which is an online tool, and sometimes if you don't want to use Hashcat or John, you can use that. just for because uh, on the runtime using Hashcat and Dawn can be a little uh, exhaustive if you may require some time to set it up. And sometimes you don't even know, don't even need to use it. For example, if in a penetration test you find some password that can be cracked by this tool online, then I don't think you need to use Hashcat or Dawn. So as you can see, this is CrackStation.net, and this is a good friend of mine, a good friend of any penetration tester. If they want to crack passwords on the run, it supports many types: NTLM, LM, MD5, SHA-256, 224, SHA-1, MySQL. So if you have any of these passwords, most time if you are doing a penetration test, you find MD5 or NTLM or SHA-256 or SHA-1 hashes, you can crack them here. For example, in this case, we have these NTLM hashes. We can paste it here. And it requires known salted hashes. And salt is a concept I have discussed somewhat in the theory, but again, uh, cracking salted hashes is another thing. It's an advanced concept that we won't cover in this video. So, most time you have to unsalt the hashes. You have to remove the salting to make the cracking process easier. And crack station only takes unsalted hashes. We solve the capture and then we press crack hash. And as you can see, it has told us that it has the type is NTLM and it has found the password for this search. Green is for exact match, yellow is partial. Most time it's either red or green. And we can try another example with SHA-256 and hopefully it works also. Again, this was the same password, but the type was different and it has correctly identified the type, and the result is again the same password differently. As you can see, uh, how much easier it is to use as compared to Hashcat and John, but uh, not to belittle those tools because those tools are great tools for cracking. And most of the time, if uh, you want to crack some Wi-Fi password, if uh, some any other kind of password that is not covered by this, or if you want to root source a password, you need to use those tools. Crack station just want to. This is good to use uh, before Hashcat if you want to just try to crack a password. If you're just trying to crack a password in very quickly, and you don't want to set up John or Hashcat because it is quite an extensive process, then you can use it. You can use Crackstation. So that was all for password cracking. Hope you guys learned something from it. I encourage you to look at other types of hashes and encryption types in Hashcat and learn more about them, and in John, and learn about salted hashes and other things. And that will surely help you in your cybersecurity job. But 90% of the time, 95% of the time, you're just going to deal with most common types, for example, MD5, NTLM, SHA, uh, Linux passwords, Wi-Fi. Most of those things were covered in this lesson. Conclusion. In this section, we looked at various password cracking tools and how we can use them to crack common password protection mechanisms. This demonstration was by no means all inclusive because of the sheer amount of various password mechanisms. This is the case for most things in cybersecurity, that is to be up to date always when it comes to various cybersecurity trends. Attackers are always improving their game and the defenders are always catching up. So keep learning and going always. Happy hacking.